Hi guys, and welcome back to my channel. In this set of series of videos, it's gonna be a bit of a big one, a bit of a biggie. What we're gonna be going over is cubic functions. Very different, very cool. However, can get a bit gross and icky, so hopefully we can get through it together. Now, in this series of videos, I want to show you how to basically graph them when you're given a table of values. I'm going to be going over how to sketch the graph. And the sketching is all very general, by the way. I'm also going to be showing you how to factorize them. So if a question asks you to find a cubic function in factorized form, what does that look like? So that's what we're going to be focusing on in this set of videos. So I hope that these are helpful to you. Okay, now let's just do a very basic intro today for this video. So I'm going to be using a table of values to help me sketch it. Now I've actually got the actual sketch there for you, but you also have to be able to do it yourself. Now whenever you're given a cubic function, now cubic functions are when you've got a rule, but the highest power is 3. So we've seen linear ones where we've got y equals mx plus c, where x has got a power of 1. We've seen quadratics, where we've got the highest power is 2, like this one here. And so then quadratics is when we've got power of 3 as our highest. And you can see it gets pretty long. Okay, so cubics, we're generally looking at a power of 3. Now, the example that I've given you here is a very basic, straightforward one. So hopefully this is a nice kind of starter point. Now, to be able to graph it, table of values is really easy to use. All you've got to do is when you're wanting to graph something, literally just substitute some coordinates into the rule and find out what your y coordinate is. So for example, I've actually written here some x values. So all you got to do is put in your calculator, for example, -4 to the power of 3, find your answer, put it here. Find your value of y when x is -3 by putting -3 in the gap where x is, and then finding your values that way. So really it's pretty easy, pretty simple, self-explanatory, and even if you are given a really, really long one, you should be able to graph them as well. But this is a really nice and easy one. So let's fill this in here. So -4 cubed is -64, times -27, -8. And these all can be found really easy in your calculator. Okay, now once you get these values, it's really easy. You can just plot these points. Now I've got the graph right here as a reference. So what you would do is you go -4, so x is -4, then y is 64. So in this one here, you can see -64 is just there. It's a really approximate graph, and you're going to keep going and you're going to go down. Now check your scale whenever you're given a graph. Do the scale unless you're doing it yourself. Make sure your thing's correct, because 3 is not here. 3 is this bit here, so it's 3, -27. So that's where this is, and so forth, so forth. And you're going to end up just connecting it as best as you can using your just freehanding it. You don't need to use a rule for this. Same with quadratics. Okay, so that's nice and easy. Now I want to just show you, what do they look like? What can cubic functions actually look like? Now there's a few different forms here. Similar to quadratics, you have several forms that the equation can be in, the function can be in. So this is kind of the few different ways it can look. So the first way here, you've got it where you've got 3 clear roots. You can see the graph has gone up and down a few times, and actually has very clear roots. Now I've got the roots in blue for you to see. Okay, so those 3 there, it goes through 3 roots, and those are P, Q, and R. I'm going to actually write that in there. Oops, not the highlighter, I don't want that one. There we go, so this is P, Q, and R. So whatever those points are, that would go into your rule here. Right, that's where they would go. And you've also got your turning points, okay? And those are the points that you would substitute in, like any one of those turning points to substitute in to find your A. Okay, so it's very similar to quadratics. So your next example, instead, you can see you've only got 1 root here. Okay, so this is a very different example here where you've got a point of inflection. Now, a point of inflection is basically where it's like a rotational point. So this section here, I'm highlighting blue, if you rotated it like 180, you would get this bit. So that's what a point of inflection is. It's a stationary point. It's almost where like it kind of changes direction. Similar to a turning point, but the idea is that it's a rotational point. Now, this is our almost like point of inflection form, where B and C are the coordinates for your point of inflection. So you're using those and substituting those in. Then you will substitute another point to find your A, or your scale factor. Because similar to quadratics, they can vary in how much they spread out or how wide or narrow they are. Lastly, I've got another graph which looks kind of similar to the first one, but it does have a special feature right here. This root is just touching the x-axis. So in fact, this graph only has 2 roots. Now you can see this is a very special graph here, the special rule where this B is the one that's just touching the x-axis. You cannot get them interchanged and you can't just switch them around. So please make sure you know that the one that's actually touching goes as B and the other one is C. Okay, so D is your intercept, so D is here, and then you've got your A, which you have to solve for by substituting a coordinate in and working it out that way. Okay, so that's the 3 major ways that you can see a cubic function.